Hi. So in this video, we are going to see the working principle of dual converter. So dual converter is used for DC drive, and with the help of dual converter, we can operate your DC motor in four quadrant. Like it can operate forward motoring mode, backward motoring mode, forward regenerative braking mode, backward regenerative braking mode. So we will explain like we'll see how these things are working. So before that, you must know like if your uh, rectifier, like it is, if it is a thyristor control full bridge rectifier and the load current is continuous, then you know like the average output voltage is given by 2 Vm by cos alpha. Okay, this is the formula. The assumption is in this particular scenario, my load current is continuous, so in that case you'll get the average output voltage like this. Okay, so now come to forward motoring mode. So in forward motoring mode, your converter 1 is will only operate, but your converter 2 you need not even fire any of the thyristors. So if you, let's say your alpha is in between 0 to 90 degree, okay, in that condition your V naught 1, the V naught 1 will be positive. And in thyristor control bridge and even diode bridge also, this I naught 1, the load current cannot be reversed. So it will be in this direction. So scenario is something like that. If you have load, this is V naught 1 and this is I naught 1. So your load is consuming power. So that means your machine is operating in motoring mode because it is consuming power. So for first quadrant, it will operate in forward motoring mode. Now come to quadrant number 4. In quadrant number 4, motor operate as a forward regenerative braking mode, operating as forward regenerative mode, you can say. So in that case, what will happen? Since I not I not 1 current cannot be reversed, if you make the polarity of the V not 1 reverse, let's say like in this way, if you can make this way, and let's say this is my I not 1, then in this condition your motor will start delivering power to source side, something we called it as a forward regenerative braking mode, because in this condition your motor side is delivering power to the AC side. You can say it is operating in inversion mode. So this can only be done. There is two condition to operate your motor in fourth quadrant. First of all, your alpha must be greater than 90 degree, okay, and your EA must be negative or it must be less than 0. So this can be done. This EA can be reversed by just simply reversing the field current direction. Let's say your field current was initially flowing some this direction, but you if you want to reverse the EA direction or EA polarity, then if you have to supply your IA like in this way, such that it will produce a field current opposite direction, okay, field flux, then your EA will be reversed. And this is something that these two condition will help us to operate your motor in generating mode, regenerative braking mode, you can say. So this is basically a very good tool to operate your machine either in motoring mode or generative regenerative braking mode. These are the like two pillar, you can say, in DC drives. So with the help of this changes, you can make your motor to operate as a kind of generator. So it will, when it will work as a generator, it will supply power and it will slow down like that. So you can also like you can once the speed of the motor gets reduced, you can apply your mechanical brake and you can brake the motor, or you can slow down the speed of the DC motor. So it is part of the converter 1. Now come to converter 2. Once you are operating with converter 1, you need not to even give any kind of supply or to any kind of firing pulse to converter to SCRs. For example, if you consider converter 2, in case of converter 2, Your V naught 2 is in this polarity, something like that. Let's say here. Okay, so it is your V naught 2 polarity, and your I naught 2 is coming like this way. So compared with V naught is this voltage. So compared with V naught is nothing but minus V naught 2, right? And you will get this polarity of voltage minus plus of V naught 2 if alpha alpha is lie in between 0 to 90 degree. In this case, your V naught 2 will be positive, but in opposite polarity. If you take this polarity plus and minus, then your V naught 2 will be just negative, simple negative. With respect to, like, if you say if you consider V naught as a reference polarity like that. So in this alpha, your V naught to polarity will be gets simply reversed. So you are you are somewhere here. Negative means you are somewhere here, and also the current should be negative. So if you consider the load current positive in this direction, like from upper to lower side, now the direction of the I naught 2 is from lower to upper. So with respect to I naught reference, your I naught 2 is something that is flowing in the reverse direction. So current will be in this direction. So your V naught is negative, your current is also negative. So you're operating in this area. In this case, your motor will operate in the opposite direction. So it is called backward motoring mode. Now in the same way, if you want to operate your motor in the regenerative braking mode, but in backward direction. So in this case, same thing you have to do. Like your alpha should be more than 90 degree, and your EA polarity must be reversed. So in that case, you can control your motor in this second quadrant also. So the thing is, by controlling the EA polarity, armature induced voltage polarity, by controlling the firing angle of the converter 1 converter 2, you can simply operate your separately excited DC motor either in motoring mode or even regenerative braking mode, something like that. So I hope it is clear. Yeah.